Look at that spinach. Look at the size of those leaves. They are massive. This is my hand. It's as big as my hand. Another kind of leaf, this one, also massive, massive leaves. And look at those kale leaves, just cuddling around that grow light. Just for contrast, here's a similar aged spinach plant from my greenhouse. Not quite as big of leaves as those other ones. Even this plant that started out rather weak and didn't take off like the other ones, this is even about the same as the ones in the greenhouse, but it's nothing compared to these ones with these huge leaves. Just glorious. Well, what is this? This is tripzero, by the way, and we're in my garage. This is my garage hydroponic system. I just wanted to show it. I actually built this over a year ago. This would be about year 2, but I haven't really attended to it or built out the infrastructure enough to really grow things in it. And now I'm growing greens as opposed to things like strawberries, which didn't do well in this type of system. And that's could be because of my inexperience, but it's doing really, really well. So let me walk you through how this system works, and I'll try to get this in one video and get it uploaded. I've been meaning to do this for a while, so let's go through the parts. It all really starts right here in the nutrient reservoir. Inside, we've got a copper coil and a pump. I'll come back to the copper coil in a second, but the pump simply pumps water up to a 4-inch PVC pipe here, which I've got angled. I've got it supported up on a weight right there, and it angled down so the water flows. As it drops down this section, it oxygenates the water as it impacts there, and it feeds all these here. Now the bottom PVC pipe, I've got it propped up a little bit higher. It's almost level all the way through. It kind of dips down just because PVC kind of dips down the middle. You could add support to make it perfectly level. But there is, we'll look in here, a almost permanent layer of water. I don't know if you can see that amongst all the roots from the other plants. This is my office basil, by the way. I stuck in here just to develop the roots a little bit more. But there's a permanent layer of water in this system. So it's kind of a hybrid NFT and deep water, although it's not that deep water, but it's got the permanent water in there. And then I've got it on a timer, the pump on a timer, where it just fills up and then drains. And this is situated, this is the drain outlet, goes back to the reservoir down there. This is situated in a place where it's not gonna, all the water can't drain all the way from this. It actually might be leaking there, which is interesting. But that's the major component of the growing system. Now the other part is the lights. These are, you can check out my other video on the water blocks. These are the first water blocks that Mike made me, and if you want some, let me know. He's still got a bunch of the new kind, which are much better than this. This was these are 3/8 inch outer diameter, and this is 1/4 inch tubing, so it was a little hard to get these on, but it's a really tight fit. And the other ones have nipples or barbs, so they're very, very easy and much easier to get those things on. And they've got built-in hooks, so I had to get the hooks for these. And the new ones are much better. You know, send me an email tripzero.kev@gmail.com if you are interested, because he's got much more and they are awesome. So these are water cooled blocks, 30 watts, 30 watt LEDs on each of them. And I've just got them hanging by a wire. Not very fancy, but it gets the job done. The plants don't care if the angle's a little off, right? But the water comes out just a little teeny tiny pump, a solar circulator pump. It was like 15 bucks. That little white thing right here. This circulates the water through the lights. This is the Reservoir, just a 4-inch ABS tube that's about 3 feet long, and it's got adapters. This is the inlet, and one on the bottom, the outlet. And just goes. This one goes through into the pump and goes up into the lights. Pink lights all the way down. About 480 watts worth of lights. Now here I've got it going into 1/2-inch tubing. It drops down into the heat exchanger. Originally, I had this going into the chiller, but that wasn't very appropriate, and I'll get to that in a second. But this is cooled by that. It's got a fan going. The fan is connected to a power supply over on the other side, and we'll go to the other side and check it out. Get a good focus picture on that, maybe. So I've been meaning to put all these electronics up on the electronic wall, but for the meantime, this is what powers the fan. This is a 36 watt adapter. Now there's probably plenty of ways to do this. This is way overkill, but I wanted to experiment as well. 36 volts, drop it down to about 14. Goes into this timer, which is about 15 bucks on Amazon. It waits for, when you flip this thing on, it waits about 10 seconds for this thing to charge up, the capacitors inside to charge up, and then flips a relay, powers up these super capacitors, which are connected. This line will go to the fan. So the reason for the super capacitors is the super capacitors allow for a whole bunch of upfront current draw, which would normally kill a power supply faster. So that's the purpose of the supercapacitor. I charge the supercapacitors up using this constant current step-down converter. Again, 36 volts, drop it down to 14 at a constant current rate. Feed the capacitor at a constant current rate, and then feed the fan, which the fan can draw as many amps as it wants. And I've got some pretty high gauge wire to support the maximum current draw that fan can pull. So that's what's powering the fan. I could probably get away with just this thing and the timer, because as soon as this thing pops up, I think it probably not pop up, but charge up the capacitors inside that thing. It's probably okay to go directly to the fan with that. So if it was a 12 volt power supply, that would be fine. The fan on this guy, the fan that I'm powering is what you typically find on a radiator. I'll walk down. That's what you would find on a radiator system in a car. So it was about 20 bucks. And I've actually gone through a lot of these, so it's really hard to find quality radiator fans, but I'm hoping with the capacitor system that it will last a little bit longer. So I've got another one of these coming that I'm going to put in the greenhouse system, and we'll try the super capacitor method in there as well, I think. But this keeps it nice and cool. I can fill this thing. It's not even warm. I did turn off the fan yesterday while I was doing some super capacitor experiments, and it did get warm. It started to get warm. This is 480 watts, nothing to joke at. This thing keeps it plenty cool, and I should have a ton of more capacity if I want to expand later on, which I may get to later. The final part of the system, which isn't hooked up, is this chiller. and I need to get a pump for it. I was using this to cool both the lights, and it was hooked into the copper coil inside, so it was supposed to cool the lights and the nutrient reservoir. The problem is the lights are too hot, so this little chiller isn't going to get it at the temperature I need to with both the lights and the nutrient reservoir hooked up, especially on warm days. So it didn't really work last year. This stuff got too warm. That was part of my problem why it didn't work out well last year. So I will just use this chiller exclusively to cool the nutrient reservoir and keep any bacteria that I don't like out of the system. So this is the upper section. Once again, this is where I can expand later on. It's got plenty of room for lights, another section of lights, and I do have plenty of blocks still left over that I could use with it. This probably won't be the same type of system. I can't keep this section level and have a drop off. I would have to rethink how I did that. But for an NFT type system, I think it would work fine. Just need to get the roots developed enough where they can dip down into the system, and I might have to increase the frequency of my watering. So what about my timer? This MFI unit is basically my timer for everything. It got it hooked up to Wi-Fi, and there's a Python API my brother and I wrote to control it, and it works really well. I've just got some code, a script written that turns on the timer on and off, turns on, and I don't even do anything with the lights. The lights are the internal software. The MFI has a scheduler. I just have it turn on at 6 a.m., turn off at 6 p.m. It's a 12-hour cycle, and then I've got a couple power supplies for the lights. I'm powering half the lights with each of these. So if I wanted to expand, I would probably get a couple more of these power supplies and converters. And each of them have their own wire going down, I think 14 gauge wire, so more than enough capacity. Having the right gauge of wire is really important. So that is the garage hydroponic system. I do have other plants growing in here. I've got some corn starters waiting to be transferred outside. Another spinach plant right there that's actually being covered. And then some tomato plants that I plan on moving to the greenhouse very soon. But this is it. Like, this is working really well. I'm really happy about the growth of these plants, and I'm ready to eat some of it. See how it tastes. So with that, if you have any questions, leave comments below. Again, if you're interested in these lights, shoot me an email. Look at my contact info on YouTube. Shoot me an email. I can hook you up with the guy who makes them. He's got plenty more. And cheers. Have a good one. Tripzero out.